measure and draw angles. In order to measure and draw angles, we need something called a protractor. Protractors often look like this. It's a tool that has several things on it that we'll be talking about. We have these in the classroom. You can get them at Walmart, Staples, that kind of place. There's usually a hole right here at the bottom. This one does not have a hole. The others that I'll show you do. This has a line. This line or hole is very important to line up with the vertex of the angle that you're measuring. Also, there are two sets of numbers. There's an inner set of numbers and an outer set of numbers. And it matters which one that you read. Both of them go from 0 to 180 degrees. So it matters on what kind of an angle that you're measuring to determine which scale to use. And we'll take a look at that in a moment. So we have this kind of protractor, nice and easy. We have these that have bars. These are nice because they help get you into the exact measurements a little more precisely. This is the kind we use in the classroom lots. It too has a bar that moves. And what I'm going to be using today is my son's. It's the same kind of thing. It's actually broken. It was broken right there because he doesn't take care of things. But what I like about this is it shows up on the white paper a little bit better than the others. So, as I said, we have a hole right here that we will line up with the vertex of the angle that we're going to measure. We have two scales. This outer scale goes from 0 to 180. So what we want to do is line up the vertex, and this would be for an angle that we're measuring something like this side. It's drawn here, and the vertex is here, and it goes up. So we would use the outer scale to measure. And if we had an angle like this, the first thing we would want to say is, well, this seems to be an obtuse angle, so it'll measure more than 90 degrees. So when we come over here and take a look at the scale, you'll see two numbers. The outer one says 120 degrees. That would certainly indicate an obtuse angle. The inner one says 60 degrees. That would not be an obtuse angle. Notice together they add up to 180 degrees because this angle is 120. This angle is 60. And together they form a straight angle, which is 180. So we'll get some practice on how to measure angles. So here are a couple that we can work with. The first thing you want to do before you actually use the protractor to measure the angle is to determine what kind of an angle do you have. This first one sure looks like a right angle. We're not 100% positive because we haven't measured it, but it's looking like it makes a square angle, so we're thinking the angle should measure 90 degrees. Perhaps it's a little bit less than 90, perhaps it's a little bit more than 90, but we are going to be looking for an answer that's somewhere around 90 degrees. If we get something that says 35, we have not measured correctly. If we get something that says 153, we have not measured correctly. We get something that says 89, well, that might be right. 92 might be right, 90 might be right, but those others would not be. So we have our protractor, we have our hole in the middle that we are going to line up on the vertex. I tell the boys and girls to stand over the work that you're doing. Don't do it from a distance when you're seated. Stand up and get right down on it so you can see what's going on. My hole is on the vertex now. Now, the hole could be on the vertex like this, but this isn't going to be helpful to measure. What we need to do is rotate this Notice how I have a ray coming off going to the right. And I want it to go right through the 0 line. And the 0 line on this protractor is on the inside track. So I'm going to be reading from 0 up. Not from 180 up or 180 down, but from 0 up. And then the next thing I'm going to do, it's good to hold the protractor down as you move things so it doesn't move. I'm going to move this bar so it's in line with the other ray. And once I do that, there's a little arrow and I can see what number it is. Remember, we were thinking that it should be about 90 degrees, and indeed, it is exactly 90 degrees. Okay. So that makes sense. It matches what we were thinking. We can draw our little box in here now, and we would say this is 90 degrees, or angle QRS equals 90 degrees. Degrees are the units of measure that we use to measure angles. This other angle we have, the first thing we want to do is determine what kind of an angle it is. And we want to make sure that we're measuring the right part. We're measuring this part, not that part. And it sure looks like an obtuse angle. This would be greater than the right angle we just measured. Therefore, the answer is going to be greater than 90 degrees. It is not as much as a straight angle, which is 180, so it'll be somewhere between 90 and 180. So let's do the same process. We put our protractor down, the hole right on the vertex. We are going to rotate the protractor so the ray going to the left goes through the 0 line. Okay. And now the 0 is on the outside, so we are going to be reading the outside scale before we read the inside scale. I'm going to move over the bar till it lines up with the other ray, and that looks good. So again, we have an obtuse angle here. We're expecting it to be more than 90 degrees, and sure enough, it is. It measures 120 degrees. So we would write angle ABC equals 120 degrees. Here's another angle. Now this looks very similar to the first angle we did, but if you look closely, you will see that this isn't quite a straight angle. It leans a little bit more, which means it's going to be an obtuse angle, which means it'll measure more than 90 degrees. Again, we put the hole right on our vertex. We rotate the protractor so the ray going to the right goes through the 0 line. We move our bar up to where the other ray is. That right on there. And sure enough, it measures more than 90 degrees. And that looks like, let me just take that in, that was about 97 degrees. So this is about 7 degrees larger. Get that lined up there. About 7 degrees larger than a right angle. So we should have letters here, X, Y, Z. The measure, and we always want to show which part of the angle we're measuring. The measure of angle X, Y, Z equals 97 degrees. So that's how we measure angles. How do we draw angles? Well, drawing angles is not too difficult if you follow this procedure. Always start with a ray that's horizontal. You don't have to, but if you do, it just makes it easier for you. So we have a ray, has an endpoint and goes on forever. We usually draw the ray going to the right, but you can certainly draw it going to the left. And if you wanted to get fancy, you could go on an angle, but it'll be easier for you if you draw it this way. Again, we are going to put our protractor with the hole at the end point. We're going to make sure the 0 is lined up here. And then we're going to move this to however large of an angle we want to measure. Let's say we wanted an angle that was 53 degrees. Well, here is 50 and here is 60. So 53 would be in between 50 and 60. There's a larger mark here, halfway. Well, what's halfway between 50 and 60? That would be 55. So 53 would be on the 50 side of 55 by 1, 2 marks. So we're going to move our pointer over 2 degrees. Hold it down, and you can put a dot or a mark in there. So now we have our ray that we drew before. We have our endpoint, and we have a mark where the other angle should be. Notice the edge of a protractor is straight like a ruler. Call that a straight edge. If you line up the 2 points, remember an angle are 2 rays that have the same endpoint. Now you have an angle that measures exactly 53 degrees. So start with a ray, nice straight ray here. Put your protractor down, move your bar to wherever you want it to go to indicate the size of the angle. Put a mark and then connect the dots. Now a question comes up, well, Mr. Owens, what happens if I'm using the other kind of protractor that does not have a bar? Like this one. And this is a typical protractor people use. Well, again, you'll line up your protractor. So the mark is on the vertex, your 0 is there. And what I suggest is either an index card or in this case, a envelope. You can line up and move it however you want. Make your own bar here. Make sure it's lined up with the vertex, and you can just put your mark there and then connect later on however large it needs to be. So you can make your own. Again, this is just a plain envelope, index cards we use in the classroom, and so forth. This is how we measure and draw angles in 4th grade.